Hello everyone. In this video we are going to investigate more about higher derivatives of functions and what does that mean. Basically, higher derivatives mean or are the same as repeated derivatives of the given function. So that is meant by higher derivatives, and in the same way we can take one derivative of a function, then we can take the second derivative, then the third derivative. It is usually written as the index but in the brackets and so on. So that is all from the theory what is needed to know about higher derivatives, and we will present some examples. So example 1, find fourth derivative of the function x squared. Answer. Now we need the fourth derivative. That means we need first derivative, then we need the derivative of the derivative, then the derivative of that derivative, and then the fourth derivative. So 1, 2, 3, 4. So we can start from x squared, then derivative of that, derivative of that, derivative of that. Derivative of x squared is 2x. Now we have three more derivatives, second, third, fourth. Derivative of 2x is 2, and we have two more derivatives. That is, derivative of 2 is 0. So, and the derivative of 0 is 0. So that means that the fourth derivative of f of x is 0. Or, if you want, if we have x squared and fourth derivative of x squared is 0. Another way, I will keep an eye on this. I will hold on this example here, x squared, and then you can make like a table basically. First derivative is x squared prime, which is 2x. Second derivative is derivative of 2x, which is 2. Third derivative is the derivative of the second derivative, which is 0. And the fourth derivative is again 0 prime, which is 0. So that means that, as we have seen up before, so the fourth derivative of x squared is 0. Well noted here is that, so note, once one derivative is 0, all higher derivatives will be 0 as well. So you can do exercise 1, and you can, let's say, find fifth derivative of the function where f of x equals x to the power 4 plus 3x squared plus x. So this is an exercise for you to understand. So first you can again make a table So you write x4 plus 3x squared plus x. Then you find first derivative, which is, I will just make here, first, second, third, fifth. Okay, so second, third, fourth, fifth. So here that will be 4x cubed plus 6x plus 1. Second derivative is the derivative of this. Then you will get something, then you put the derivative, and so on. So that's your task. I just started there to help you a bit with that. Okay, example 2. Find fourth derivative of cosine x. Okay, answer. So we can again do the table. So cosine x. Then first, second, third, and fourth. Here. So we can write here cosine x is like the function. First derivative is minus sine x. Second derivative is the derivative of this. Then we make a derivative that is minus cosine x. Then we take the derivative that is minus sine x, which is sine x. And then we again take the derivative that will be cosine x. So we can say the fourth derivative of x is cosine x, which is f of x. So cosine x has that feature that it is the same as its fourth derivative. You can proceed and then you can see that fifth derivative is then the same as the second derivative. Sixth derivative is the same as first derivative, not second. So first. Sixth derivative is the same as second. Seventh derivative is the same as third derivative, and eighth derivative is the same as the fourth derivative, which is the same as f of x. That means that derivatives, you can investigate this, derivatives of cosine x follow modulo 4 repetition. So if n equals 4n, then f of 4n of x is f of x. If n is 4n plus 1, then f of 4n plus 1 f of x is the second derivative minus cosine x. The first derivative minus sine x. If n is 4n plus 2 and n is 4n plus 3, then f of 4n plus 2x is minus cosine x, and f of 4 to the power, so 4n plus 3 derivative is sine x, and this is cosine x. So if someone asks you to find f 100th derivative of cosine x, 100 is 4 times 25, so that belongs to this group here, and therefore that is cosine x. So this is equal is cosine x. Example 3. You have f of x equals e to the power x. For every n, the nth derivative of x is just e of x. So this is easy because every derivative of e to the power x is, and then if you take second derivative, that is again the same function. So I hope these 3 examples have helped you to have an insight of what repeated or higher derivatives are, and it is just meant to repeat derivatives to every new function that we obtain when we apply derivatives. Thank you.